This is it, Dragons, page 27, solving equations using inverse operations. So this is actually the hardest of all the videos because I haven't shown you all this material before. This is going to look pretty brand new for some of you. Some of you might have seen it in prior years or on iReady, but most of you, this will be new. Now, if you've done the inverse operations on the prior two pages, you'll be a little bit ready to handle this. If you're tired at this point from doing the other pages, I would definitely pause and wait to do this page. Now, if you're ready, let's begin. Solving one-step equations. When they call it one step, they pretty much mean one operation is occurring. One operation. Not too fancy. Solve equations by applying the inverse operation, which is why we went to all the trouble to identify inverse operations. To isolate, which means to get alone, the variable, and all that's saying is I want the variable to live by itself, you have to use undoing of the operations. You want to undo the operation. For example, let's say we had x plus 3. To get x alone, we'd have to take away 3 from it. And then that would make it go away, because plus 3, take away 3, means you have nothing. So x would be alone, which means you isolated the variable. If we had x minus 4, to get x alone, I would have to add 4. Minus 4 plus 4, nothing left. X lives by itself. Let's say I had x multiplied by 5, 5x. To get x to live by itself, I would have to divide by 5. 5 over 5 is 1, so I'm down to just 1x, which is just x. Lastly, I might have x divided by 6. The opposite of dividing is multiplying, so I'd have to multiply by 6. You might remember that there's an invisible 1 there. Well, you can cross-cancel here, or you could work it out the long way. But either way, what you get in the end is just x. Just x. So this 6 cancels out. Now we're going to apply this knowledge to some of these problems here to actually find the value of x. We're finally at that stage where we're no longer just expressions. We're going to get to an actual answer. X plus 9 equals 17. Well, you might be able to tell yourself in your head, well, I know the answer to that because something plus 9 equals 17. I just have to figure out the something. Well, let's use inverse operations to do it. Now, I do this in a very particular way because they get more complicated as you go on in mathematics, so I try to be very organized with my work. Equal signs means there is a balance. What you're doing to one side needs to occur on the other side. X plus 9 is worth 17. If I take away 9 on this side, because I want to isolate the variable, which means to get x to live alone, and I will. To be fair, I have to do the exact same thing to the other side of the equal sign, which would be take away 9. You'll notice that I'll be very organized with this work. A positive 9 and a negative 9, or plus 9 and minus 9, they cancel out, which means it kind of goes away. Which means x is all alone. X comes down, x will be here. Your equal sign comes down, it comes here. Now you actually do 17 minus 9. This side is, what is 17 minus 9? It's 8. So your happy answer, x is worth 8. How do you know if you're right? Is 8 plus 9, 17? That is true. Let's try the next one. X minus 7 equals 15. First, you ask yourself, what is the operation happening? The operation is subtraction. What is the opposite of subtraction? Addition. I need to add 7 to get x to live alone, which means to isolate the variable. So I'm going to add 7. But since this is an equation and not just an expression, I have to be fair. And if I do something to one side of the equal sign, I have to do the exact same thing to the other side of the equal sign because I want it to maintain its equality. So I'd have to add 7 here too. Minus 7 and plus 7 cancel out. X lives alone. Your equal sign comes down. 15 plus 7 is 22. X was worth 22. Let's check if that's true. If X was 22, 22 take away 7 is 15. True or false? True. That means you did it right. 3x equals 18. First, ask yourself, what is the operation occurring between 3 and x? Multiplication. What is the opposite or inverse operation of multiplication? Division. So I want to get x to live by itself. So if it's being multiplied by 3, now I need to divide by 3. But just like in the previous problems, if I do that to one side of the equal sign, I have to do the exact same operation to the other term on the other side of the equal sign. So 18 also has to be divided by 3. 3x divided by 3 means x lives alone. 18 divided by 3 is 6. How do I know if I'm right? 3 times 6 equals 18. True or false? True. So you've done something right. Last one of our one-step equations. N divided by 3 equals 5. First, you ask yourself, what is the current operation? That would be division. Then you ask yourself, what is the opposite or inverse operation of division? That would be multiplication. So to get n to live by itself or to isolate the variable, I need to multiply. Multiply. N is being divided by 3, so now I need to multiply it by 3. To be fair again, if I do it to one side of the equal sign, I have to do it to the other side of the equal sign. This cancels out. N lives alone. Your equal sign exists. 5 times 3 now occurs, and you get 15. You check your answer by asking yourself, if n is 15, and I divide it by 3, will I get 5? True or false? True, I will. I'll get 5. Those are one-step equations. One operation. You do one inverse operation. Next are two-step equations. Solve equations by applying the inverse operation. But here, if it says two-step equations, that means there's two operations. To isolate the variable, or to get the variable to live alone, you have to undo whatever operation is happening. So I can have all sorts of variables, yes? And all sorts of things can be happening to these variables. I could be adding something, subtracting something, multiplying something, or dividing something. But in order to do the solving, in order to actually get the answer of x, I have to get x to live alone. So I have to do the inverse operation or the opposite operation. So if I was adding 2, I'd have to take away 2. If I was subtracting 5, I'd have to add 5. If I was multiplying by 7, now I need to divide by 7. If I was dividing by 3, now I need to multiply by 3. You do the opposite to get x to live alone. You want x to be by itself. That's how you determine what its value is. Now, these two-step ones are tricky but fun because they only get more complicated as time goes on. I like to think of these as the order of operations in reverse. So if normally I would multiply and divide first, I'm going to do just the opposite. I'm going to multiply and divide last. So it's like the order of operations in reverse. So that's what's about to happen here. First, we need to identify everything that's happening. 5 times x plus 8 equals 23. X is being multiplied by 5 and 8 is being added to it. 2 operations, multiplication and addition, which means I'm going to need some division and subtraction because I got to do the inverse ones. But first we need to make the 8 go away. So to do that, I need to subtract 8 from both sides of the equal sign. That makes that go away. 5x was unaffected in that it's still 5x. The 8's cancel out, your equal sign comes down, and then you do 23 take away 8. That's 15. Now you have not finished. X isn't alone, and you don't know what just x is. In order to get x alone, I need to do the opposite of multiplication, which is division. Divide by 5 on both sides of the equal sign. That cancels out, so x finally lives alone. Your equal sign comes down, and now you do 15 divided by 5, which gets you 3. How do you know if you're right? You substitute the value back in for x. So it would be 5 times 3, which is 15, plus 8 equals 23. True or false? True. You did it right. Excellent. Now we've got 7n divided by 3, subtract 6, equals 8. You could see this as possibly 7/3 n. You might be seeing it in that perspective. You might be seeing 7n divided by 3. I could see you interpreting this in a variety of ways. I do know that I've got some kind of fraction thing going on, and I definitely have subtraction. The opposite of subtraction is addition. Remember, we're doing order of operations in reverse, so you're going to start with your addition and subtraction, then move to multiplication and division. So I'm going to add 6 to both sides. So 7/3 n, these cancel out, equal sign comes down, 8 plus 6 is 14. 7/3 n equals 14. N has not been isolated yet. It does not live alone. I can get n to live alone if I multiply by the reciprocal here. 7/3 n, if I multiply by 3/7, 3 times 7 is 21, 7 times 3 is 21. I have 21 over 21. Something over something that's the same number as 1. I have 1n. I just made these cancel out. But if I do it to one side of the equal sign, I got to do it to the other side. So now I need to do 14 times what? 3/7. Now, take a minute and work out that math. That might take you a second, which is fine. I happen to know that I can cross cancel here because I can put 7 and 14, 1 and 2. So I've just got 2 times 3. N comes down. I know that n is going to be worth 6. How do you know? You can go test it. 7 times 6 is 42. 42 divided by 3 is what? This might take a second. 42 divided by 3. Not sure? Let's work it out. 14. 14 take away 6 equals 8. True or false? True. You're correct. Fantastic. All right, last one of this lineup is solve a two-step equation by combining like terms. Well, we went to a lot of trouble to simplify expressions. Well, you can simplify equations too. And then when you simplify them, then you can solve for the variable. I'm going to show you how this works. You're going to combine like terms, then isolate, which means get the variable to live alone, using inverse operations. Well, if we need to combine like terms, I think we need to make one of our little charts. But what you need to know is you can only combine things on one side of an equal sign. These are separate from these. So I am allowed to combine these ones on this side. This one has nothing to combine with on its own side. This one already lives alone. It's fine. So we need to make this one more simplified. Looks like I have a 5x, basically a negative 6, and a 4x. How many x's do you have altogether? 9x. If you were setting up your chart, you would have x's and constants. You would have 5x and 4x, which resulted in 9x. Who's your constant? Got this like negative 6 going on, or subtract 6. So we've got 9x subtract 6. We took care of that side. We already said we can't do anything to 12 because it can't get any simpler than that. So 9x minus 6 equals 12. Now that you have simplified this side, you can solve for x. 9 times x, take away 6 equals 12. What operations are happening? I see multiplication here and subtraction here. To do the opposite, to get x alone, I would have to do some division and some addition. We're going to start with the addition. Add 6 to both sides of the equal sign. What you do to one side, you have to do to the other in order to maintain equality. The minus 6 and the plus 6 kind of undoes itself. So now I have 9x equals, now you have to do 12 plus 6, which is 18. Now the question asks, 9 times what equals 18? The proper way to do it algebraically is to divide both sides by 9. 9 is being multiplied by x, so the opposite would be to divide. Do it to one side of the equal sign, you got to do it to the other side. The 9 over 9 cancels out to be 1x. X is going to equal to 18 divided by 9. Well, 18 divided by 9 is 2. So x will equal 2. How do you know if you're right? I'm going to show you very quickly. I'm going to rewrite the original expression right here. I'm going to take the value that we figured out should be correct and substitute it everywhere where I see x. I'm going to do 5 times 2, subtract 6, plus 4 times 2. I'm going to use order of operations here to simplify this. I've got 5 times 2, which is 10, take away 6, plus 4 times 2, which is 8, so I kind of did both parentheses simultaneously. 10 minus 6 is 4. 4 plus 8 is 12. True. Which means x really does equal 2 in this equation. So this one should have been your most challenging page today. We are definitely going to go over this more in the future. But now you have the steps, you have the notes, and so when we visit this in the classroom, you'll be prepared to begin solving one-step and two-step equations. Thank you for doing your homework this weekend. I appreciate your time.